Hi everyone, thank you for being here today. My name is Rami, this is Daniel, and today we will be speaking about API security. We were supposed to be with Reem together as well, but she couldn't make it unfortunately. So today we'll be speaking about API security, which is a very trending topic, very important nowadays, especially with APIs. In specific, we'll be speaking of BOLA, which is Broken Object Level Authorization. And our title is the Open API Extended Security Scheme. And what we suggest with this is that we're trying to show a new security scheme, an extension of the existing security scheme that includes authorization checks, because the current security scheme of the Open API spec has some limitations with this. Let's get going and get started with APIs, a quick introduction. Like many of you are familiar with APIs, we all know what APIs are, and we know many of the technical details. But let's still look at the basics, because some of the security features that we do not have are reasons of limitations with the foundation of remote procedure calls and the messaging technology behind that, which is interface description languages. So we all know that APIs are remote procedure calls in their foundation, and these enable inter-system communications. They do so using IDLs, interface description languages, and an IDL can be seen as a bridge between two systems, which allows message passing from one to the other. Commonly with RPCs and APIs, you have Java, for example, on one side, Python on the other side, or any other language, and you need a programming language independent technology that facilitates this interpassaging of messages. While doing so, IDLs cause an issue because they do not have awareness of objects, and objects are what API metadata is. And when there's no awareness, you cannot apply anything on this. You cannot apply security property like authorization, and as a result, you do not have object level authorization. So we'll get back to why IDLs are so important to this. But first, let's look at the API top 10 listed by Owasp for security risks. Number one is the broken object level authorization. There are many examples of breaches in the last few years. 2019, Uber was a famous one. A more recent one was in the Netherlands with the COVID situation, where the government had data of all the citizens, and people working there could access sensitive personal data without being able to do so. Some others are broken user authentication, broken function level authorization, but we'll be focusing on BOLA here today. Let's look at what BOLA is in a bit more depth. So the definition would be that it is when authenticated users manage to gain access to data which they're not authorized to. And this happens because currently there is no such program standard in the Open API spec to develop and define this authorization mechanism. Developers tend to do it by themselves. They need to code it on the go for every different application. There's no guideline for it, for the Open API specification that is. And this leaves a big room for errors. It makes for sloppy programming. You don't have best practices. That is one of the big reasons that BOLA is so prevalent and common in the industry nowadays. It's also one of the most easily exploitable vulnerability when it comes to APIs, and that is also why it has been listed as the #1 API. So the way BOLA actually happens, on the far right you can see a simple example. But in practice what happens is that someone, the malicious attacker, takes an input, changes the input. It might be a UUID, guessing one, or using tools to find the one that you want to utilize to guess for data of other users. And when having that, they manage to get access just like that because there's no mechanism that prevents them from gaining this. So why is solving this so difficult? For the same reason that developers are focused on speed rather than security. They want quick output, they want to get code to market quickly, and security is often left as an afterthought. So what we suggest to tackle this issue is to simplify security, to bring security, to remove complexity from the developer side, to bring it to the background so that developers can focus on speed still as they find important, whilst security becomes a standard in the Open API specification, authorization that is. So as we said, there are no authorization technologies currently in the spec, apart from the OAuth scopes, but these scopes are often being overused and stretched beyond their original use case. because scopes are mainly meant for delegation and identity federation purposes. Also, if you use scopes, they are still not object-centric. They're not surrounding object authorization. So what we suggest to solve this is that we want to extend the security scheme and make the scheme, which is the Open API spec, aware of objects themselves. And we want to do this by assuming the principle of least privilege, making sure that no object data can be accessible unless the rule has been given that it can be accessed. So a deny by default principle. And we do this by defining object definitions in the specification itself, and we'll soon go over the code and how we did this. One requirement for this is that the generator, the current generator, is not able to grasp those differences. So what has to be done is that the generator needs some additions, some changes. For our demo, we built a private generator that has the capability to read these declaratives. We'll be showing that soon as well with Daniel later in this presentation. So the typical flow of a software-based approach when building an API is that the developer codes it using one of the popular frameworks, FastAPI, Flask, or many others, and then uses a code spec generator or the inbuilt one from the framework itself to develop the specification as well as the code itself. There's another approach, the design-based approach. This is far less common, but sometimes it's referred to as more best practice, more preferred by API security enthusiasts. So a developer defines the API definition file, also known as the spec, in YAML or JSON, and then uses the Swagger code gen or another generator to output the server stuff itself. This is the typical process. No authorization is taken into consideration in this. What we want to do instead to overcome BOLA or to reduce the prevalence of BOLA is we introduce a module, a Python module in this case, that provides object level authorization. So in this case, when using this module, what would happen is that the developer writes code, imports this module. It could be on pip, PyAPI, and then the generator, which is the private generator that we have, which is aware of these changes, would be able to read this and place it in the specification itself. And the way this makes it simple for the developer is that we're using declarative security here, so a declarative style of coding, which means that the developer only has to define the access control list rules, and complexity of authorization is handled in the background. And one of the benefits is that if we have a public module, an open source one, is that it's constantly vetted, it's improved, it becomes a quite solid framework, and developers can follow a best standard guide to implement object authorization, therefore reducing the chance of sloppy programming, poor code construction, which leads to BOLA. So a bit in more depth, let's say in runtime, how would that object authorization module work? We'd have the user, and the user would log in with the username and password to the API service. What would happen is that the service would return a token, and this token has a user ID bound with a group. And this example that we built is based on role-based access control. So a user in a specific role, let's assume that a role A has ownership of a certain object. So the users in this role, other users in the same role can have access to the object as well. But if you are in a different role that is not listed in the ACL, which we'll go over soon, then you're not granted this access. Now let's say that you're authenticated. And step 2, authorization. The user wants to create an object. We do an HTTP post request in the path user with the token that was granted in step 1. What then happens is that this is placed in an ACL, an access control list, this entry. That is only if this part is authorized. That is the user, which just made a post request, made it to a path or a directory where authorization is granted. Then we go to step 3. Let's say that the same user or another user wants to update this object in a certain path. What happens is that the user would make the request. First, we have a comparison between the user ID of the person making the request and the user ID of the object creator, which is in the ACL down below. So if there is a match, then authorization is granted. But if there is a mismatch, if the user is not in the same group ID, then what we have is a return 401, lack of authorization, so the request is denied. And this can be a BOLA attack, which is one of the ways to avoid it in this case. Now, in the design-based approach, step 2, it is slightly different because developers would start from the Open API spec, API definition file itself, and they would define the object-level declaratives, the security declaratives. These do not exist yet in the current standard, but we have made some changes which introduce them. What would happen is that the developer can use these, use the generator which would be aware of such declaratives, and then generate the service stub code, which has the access control list lines already there for object access and requests. And this is an example of what we did. We took the pet store, which is a common API service for testing and development. And what is highlighted in yellow is what we've added. So if you look at the bottom, the global root level declaration, we added something called XObjectOf scheme. So the existing standards that can be used from the documentation is API key, OAuth 2.0, basic authentication, etc. XObjectOf scheme would refer to the idea of presenting object authorization in that list as well in the documentation. And with that, developers would be able to define object access privileges. On the far right, which you can see is the XObjectOf over there, expanded. And what we're trying to do there is reduce the amount of work developers have to do. So that module on the far right can be reused. The only thing a developer has to do is on this part, refer to the objects that are present, and then the rest gets auto-populated so that we reduce the amount of work and we reduce the code, make it as little as required to make it work. So, now I hand it over to you, Sherman, to speak of the demo as well. Go ahead.
Thank you, Rami. Hi, everyone. Let's talk a little about development. So, as Rami said before, we needed to create a generator who could understand the declaratives that we added. And in the first place, we wanted to try to modify Connexion, which is a Python framework which basically creates APIs based on Open API Specification. But after that, we decided to create a lightweight version, something that was custom made. And this could work in both ways, to generate from code to spec and also from spec to code. And let me give you a little bit information about how does it work. So, for example, when we go from the software-based approach, we assume that we have an API, the API code that's working, and what the generator does, it checks if the authorization module is imported into our code. If that is checked, then the API server stub is read line by line, and first thing, the authorization module is read and is checked where is the location of the ACL, where is the location for the authorization token, and so on. And after that, scans the file, goes line by line for every path, and checks if authorization checks are set for that specific path. After all this is done, then the spec is generated. If we go for the design-based approach, generator reads the spec and copies the authorization module to the desired folder, where we will have the API server stub. After this, the API code is generated based on the extended security scheme. And for every path, that was defined in the specification that needs authorization, authorization checks will be added. One last thing, the authorization module will be verified and modified if needed based on the specifications in the spec file. After all this is done, the API code is generated and ready for further development done by the API developers. More information about the authorization module. We used a Flask server as an API for this proof of concept. And we managed to link the authorization module to the API using Python decorators, which was an elegant way and which meant that developers didn't need to add any authorization logic in their code. Everything is done in the authorization module, so it's totally invisible to them. One last thing that we found that, as a challenge was the fact that we needed somehow, when we create an access list entry, to make sure that we identify one single object. And if we take, for example, MySQL server, and we have an entry, we will have for that specific object one ID. But if we have several tables, we will have an access list entry with the same ID. So we needed somehow to generate an UUID. And how we did that, we used the ID from the table and also the name of the table. So this pair that we found is used as an UUID in the access list entry. We also used for the generator, we used Jinja templating to generate all the code and also the spec file. And also we used JWT in order to send information regarding username, user ID, group ID, and so on. So as a demo scenario, we'll have a legitimate user who authenticates to the API, creates an object, in our case, a pet. The malicious user authenticates the API, tries to read the file, the object, and he'll get a 401. And bolo attack, basically, it's averted. Give me one more second. Okay, let me zoom in a little. Okay, so for example, what do we have in our folder? We have a specification file, which which is our example with the pet store. It has just one object. It's the pet, and we have a put, a get, post, and so on. And at the end of the file, we'll have our declaratives, what we added. So we know that we have the JWT in the header, and we know that we'll have the ACL file we'll have the location for the ACL in a file. We were thinking that we could save it in the file and also encrypt it to make it more secure. But for the sake of the demo, we'll leave it and encrypt it just to be easier. Okay, so let's run the demo. First, if we go. It's spec. Oh, sorry. I did it. Okay. So, for example, based on the spec, we ran the generator, and we got one skeleton of a Flask server, which has the pet with every HTTP verb with a put, with a post, a description, and so on and so forth. Also, we have some hard-coded or some special functions, which is a special path with this object permission. But I'll explain in the demo a little bit more what it does. And for the authentication, we hard-coded two users in order to do the demo. We have a user named user and another one who's called hacker. OK, good. Moving on. Also, the generator works in reverse. From code, you can generate the spec. And let me show this also. OK, based on the API, on the API.py file, the code, we were able to generate the spec, which is the exact spec as the first file that we presented. OK, and now just showing you a little bit the demo. We go like. OK, so we launched the server, and now we'll bring Postman into play just to see the following use case. So we have the legitimate user, makes a request, receives a token. With this token, we go and create a pet. I put here some information just to have something here. And we receive a 200 code, and we see that we have the username user, we have the user ID, and what's very interesting is that we have here ID 47. So this is just a mock, like we have the ID from the database. And also we have a category which is called pet. Good. After we do this, we can do, for example, one read. And also, we can see the object privileges for this specific object. We have the ID, we have the category, we have the user read-only users list, and list with read and write user IDs. For example, I have 1, 2, 3, the user ID for the user who created the object. After we do this, now we're turning it into the hacker. So we log in. We got a different token. We try to read the same object that the first user created. We get 401. If we try to see the object privileges, we got 401. Also, if we try to change the object privileges, as expected, we'll get 401. But what we can do with this object privilege path that we talked a little bit before, we can go back as the user. OK. We log in again. We get a different token. We see that we are able to read the object from before. And here we see that we can update the access list entry. We can tell it that for this specific object in this category, read-only users, here in this list, we will add the user ID 133, which is the ID associated to the hacker account. When we do this, we just send it. It's a 201 created. We can check to see the object privileges, we see that for read-only users, we have added user ID. And what we can do, we can go back here, log in as hacker, and we go and read that certain object. We see the object, and now if we go to the privileges, we are able to see the privileges, but if we try to change something, we'll get 401. So, yep, that's pretty much it about the demo. I hope you enjoyed it, and now let's continue with the presentation. Okay. So key takeaways. Basically, we managed to find a way to reduce BOLA. And also, we provided a way to make easier for developers to write code and write secure code. And yep, that's pretty much it. Thank you very much for your attention. This is my team, Rami, me, and Reem. Yeah, thank you for your time. If you have any questions, yeah.
Right. So the example you are showing is for experience API, where there is some user involved in invoking the action which comes to your API. Right? But there are many APIs where an application is invoking the API. There is no user, it's a big system, application to service scenario, there is no user involved. How does it work for those scenarios where you don't have any users?
So
the application, right, there is no user interface associated with application. But you still want to enforce access control on your API. So these are not experience API, these are process or system API, right? How do you use your framework?
So the authorization itself is not bound to users. It's object-centric, object-oriented access control. So that is one of the reasons also that scopes and other methods we do not want to, they're not recommended for this, for preventing BOLA. Because as you said, there is not always a user. But when we use object-centric authorization, what we can achieve is authorization surrounding the object, so it has to be tied to the object itself. So it might not be a user that's trying to access it. It can be anything. It can be a recurring request as well, an automated request or a hook maybe. But the idea is more to present the concept of introducing these declaratives to the security specification to add the missing authorization capability. And what we want it centered around objects themselves. But in our demo, it is mainly about users, but it can be expanded to non-users and
Yeah, I have a follow-up question.
yeah.
How would this work with, let's say, a user or application is authenticated using OAS? So there is ID token there available to you. How would this work with OIDC?
We didn't look too much in depth about OIDC. We've read about it, we considered it, but we didn't treat it for this part. We narrowed it down very much to one technology. But yeah. Thank you for your question. Any other questions in the audience? Yeah.
Yep.
Thought about how to extend it generally to dynamic lists. So for instance, the social network connection depth, right, where I have a host and I dynamically want to choose if it's either readable by the world, readable by my personal connections, or readable only by me. Is that kind of granularity or programmability of the authorization something about?
Yeah, for now it has two options. When it does the checks in our demo, basically it first checks if you have the right group ID and if not, it will search for one specific user ID. So it has two stages, two parts. We call it like that. Thank you.
Any other questions? Okay, thank you everyone.
Okay, thank you.